Thomas "Tommy" Harold Flowers, MBE, was a British engineer. During World War II, Flowers designed Colossus, the world's first programmable electronic computer, to help solve encrypted German messages. Early life. Flowers was born at 160 Abbott Road, Poplar in London's East End on the 22nd of December 1905, the son of a bricklayer. Whilst undertaking an apprenticeship in mechanical engineering at the Royal Arsenal, Woolwich, he took evening classes at the University of London to earn a degree in electrical engineering. In 1926, he joined the telecommunications branch of the General Post Office, moving to work at the research station at Dollis Hill in northwest London in 1930. In 1935, he married Eileen Margaret Green, and the couple later had two children, John and Kenneth. From 1935 onward, he explored the use of electronics for telephone exchanges. By 1939, he was convinced that an all-electronic system was possible. This background in switching electronics would prove crucial for his computer design in World War II. Flowers' first contact with the wartime code-breaking effort came in February 1941 when his director, W. Gordon Radley, was asked for help by Alan Turing, who was then working at the government's Bletchley Park code-breaking establishment 50 miles northwest of London in Buckinghamshire. Turing wanted Flowers to build a decoder for the relay-based bomb machine, which Turing had developed to help decrypt the Germans' Enigma codes. Although the decoder project was abandoned, Turing was impressed with Flowers' work, and in February 1943 introduced him to Max Newman, who was leading the effort to automate part of the cryptanalysis of the Lorenz cipher. This was a high-level German cipher generated by a teletypewriter inline cipher machine, the SZ4042, one of their Geheimschreiber systems, that was called Tunny by the British. It was a much more complex system than Enigma. The decoding procedure involved trying so many possibilities that it was impractical to do by hand. Flowers and Frank Morrell designed the Heath-Robinson, the first machine designed to decrypt the Lorenz or fish machine ciphers. Flowers proposed an electronic system, which his staff called Colossus, using perhaps 1,800 thermionic valves, and having only one paper tape instead of two by generating the wheel patterns electronically. Because the most complicated previous electronic device had used about 150 valves, some were skeptical that the system would be reliable. Flowers countered that the British telephone system used thousands of valves and was reliable because the electronics were operated in a stable environment with the circuitry on all the time. The Bletchley Park management were not convinced, however, and merely encouraged Flowers to proceed on his own. He did so, providing much of the funds for the project himself. Flowers had first met Turing in 1939, but was treated with disdain by Gordon Welchman, because of his advocacy of valves rather than relays. Welchman preferred the views of Wynne Williams and Keane of BTM, and wanted Radley and Mr. Flowers of Dollis Hill removed from work on Colossus for squandering good valves. On the 2nd of June 1943, Flowers was made a member of the Order of the British Empire. Flowers gained full backing for his project from the director of Dollis Hill, G. Radley. With the highest priority for acquisition of parts, Flowers' extremely dedicated team at Dollis Hill built the first machine in 11 months. It was immediately dubbed Colossus by the Bletchley Park staff for its immense proportions. The Mark Chapter 1 Colossus operated 5 times faster and was more flexible than the previous system, named Heath-Robinson, which used electromechanical switches. The first Mark Chapter 1, with 1,500 valves, ran at Dollis Hill in November 1943, and then at Bletchley Park in January 1944. A Mark Chapter 2 redesign utilizing 2,400 valves had begun before the first computer was finished, in anticipation of a need for additional computers. The first Mark Chapter 2 Colossus went into service at Bletchley Park on 1 June 1944, and immediately produced vital information for the imminent D-Day landings planned for Monday 5 June. Flowers later described a crucial meeting between Dwight D. Eisenhower and his staff on 5 June, during which a courier entered and handed Eisenhower a note summarizing a Colossus decrypt. This confirmed that Hitler wanted no additional troops moved to Normandy, as he was still convinced that the preparations for the Normandy landings were a diversionary feint. Handing back the decrypt, Eisenhower announced to his staff, "We go tomorrow." Earlier, a report from Field Marshal Rommel on the Western defenses was decoded by Colossus and revealed that one of the sites chosen as the drop site for an U.S. parachute division was the base for a German tank division. The site was changed. Years later, Flowers described the design and construction of these computers. 10 Colossi were completed and used during World War II in British decoding efforts, and 11th was ready for commissioning at the end of the war. All but 2 were dismantled at the end of the war. The remaining 2 were moved to a British Intelligence Department (GCHQ) in Cheltenham, Gloucestershire, where they may have played a significant part in the code-breaking operations of the Cold War. They were finally decommissioned in 1959 and 1960. Post-war work and retirement. After the war, Flowers was granted £1,000 by the government. Payment which did not cover Flowers' personal investment in the equipment, and most of which he shared amongst the staff who helped him build and test Colossus. Ironically, Flowers applied for a loan from the Bank of England to build another machine like Colossus, but was denied the loan because the bank did not believe that such a machine could work. He could not argue that he had already designed and built many of these machines because his work on Colossus was covered by the Official Secrets Act. His work in computing was not fully acknowledged until the 1970s. His family had known only that he had done some secret and important work. He remained at the Post Office Research Station where he was head of the switching division. He and his group pioneered work on all electronic telephone exchanges, completing a basic design by about 1950, which led on to the Highgate Wood telephone exchange. He was also involved in the development of ERNI. In 1964, he became head of the advanced development at Standard Telephones and Cables Limited, where he continued to develop electronic telephone switching, including a pulse amplitude modulation exchange, retiring in 1969. In 1976, he published Introduction to Exchange Systems, a book on the engineering principles of telephone exchanges. In 1977, Flowers was made an honorary Doctor of Science by Newcastle University. In 1980, he was the first winner of the Martlesham Medal in recognition of his achievements in computing. In 1993, he received a certificate from Hendon College, having completed a basic course in information processing on a personal computer. Flowers died in 1998, aged 92, leaving a wife and 2 sons. He is commemorated at the Post Office Research Station site, which became a housing development, with the main building converted into a block of flats and an access road called Flowers Close. He was honoured by London Borough of Tower Hamlets, where he was born. An information and communications technology centre for young people, the Tommy Flowers Centre, opened there in November 2010. The centre has closed, but the building is now the Tommy Flowers Centre, part of the Tower Hamlets Pupil Referral Unit. In September 2012, his wartime diary was put on display at Bletchley Park. A road in Kesgrave, near the current BT Research Laboratories, is named Tommy Flowers Drive. On Thursday, 12 December 2013, 70 years after he created Colossus, his legacy was honored with a memorial commissioned by BT, successor to Post Office Telephones. The life-size bronze bust, designed by James Butler, was unveiled by Trevor Bayliss at Industrial Park. BT's Research and Development Centre in Martlesham Heath, near Ipswich, Suffolk. BT also began a computer science scholarship and award in his name. Bibliography. Copeland, Jack ed. Colossus. The Secrets of Bletchley Park's Code-Breaking Computers. Oxford. Oxford University Press. ISBN 978-0-19-284055-4. Flowers, Thomas H. D-Day at Bletchley Park, in Copeland 2006, pp. 78-83. Randall, Brian. Of Men and Machines, in Copeland 2006, pp. 141-149.